The universe has particles, electrons, photons. Some of them have mass, others do not, but all of them move, and some of them like to move through each other. Electrons and photons don't. They like to bounce off each other due to something called Compton scattering. But how can we show this bounce? Well, we have to solve for their trajectories, and this means solving for their wave function. Classically, wave functions are functions on configuration space, which means their inputs are the positions of particles. But since we have photons, this means we are dealing with relativity, which means that particles not only have their own positions, but their own times. Our segment focuses on three particles, one photon between two electrons in one spatial dimension. Their wave function is a vector with 8 components and has 3 multi-time partial differential equations. If we take our electrons to be massless, then we are left with transport equations, which means each wave function component will be transported in a direction at the speed of light. Take minus plus plus. That wave function travels in a direction corresponding to our photon moving to the left, while both our electrons move to the right. That means that the photon will cross one of the electrons after some time, and we can't have that. So we have to introduce boundaries into our configuration space. Probability has to be conserved, which means any probability leaving our boundaries must be replaced or reborn in the form of one of our other components, which leads to our bounce. But let's introduce some mass into the equation. This turns both of our electron transports into massive Dirac equations, which means that our data will now be spread out along a square rather than a condensed line of transport. Since one of our PDEs, the photon one, still follows the massless transport, we find that 4 of our components will have squares transporting in one direction, while the other 4 components will have squares transporting in the other. Just like before, we need to make sure that our particles don't cross each other, which means putting in boundary conditions. And we find that the rebirthing mechanism still holds. As one of our squares passes through the boundary, another wave function component is continuously born to replace the probability lost. Each point of this newly born data will also spread in the form of a square, giving us this lovely video.